Okay, so when we start doing some problems with heat, it's really not that, it's not hard. You just got to know the formula. Here's the problem that we're going to do today. It involves swords, which are awesome. And the thing about a sword, though, is it's not small, and that comes in here when you think that the mass that we're dealing with is kilograms instead of grams. So I'm just going to read this in case you couldn't read my writing, and take down the numbers, and then try to do the problem while you know you're watching the video. Sort of pause it, and then don't play my solution until you've gotten yours. An iron sword with a mass of 3 kilograms is cooled from 198 degrees Celsius to 85 degrees Celsius in a large water bath. And we've all seen that, in the movies where they take the red hot sword and it goes like that into the water bath, and it rapidly cools it, and hardens the steel. How much energy does the iron sword transfer to the water? Okay, so we're assuming that no water boils, and that's more for the second part of the problem that we'll do in a second. But Q equals M specific heat delta T. Okay. So this is the formula we're going to be using here, and then this is just the energy in joules, the mass. Now it's got to be mass in grams, specific heat, and change in temperature. So the change in temperature is defined as the final temperature minus the initial temperature, which in this case is going to be interesting because the final temperature should be less than the initial temperature because it's cooling down, and since it's cooling down, we're going to get a negative answer for the heat because the energy is being transferred out into the system. In this case, it's going to be the water bath. So the first thing I look at is it's 3 kilograms. So 3 kilograms is actually pretty heavy because a kilogram is 1,000 grams. So I'm just going to go here and go 3 kilograms times 1,000 grams in 1 kilogram. So I actually have 3,000 grams. So my mass that I'm plugging in is 3,000 grams. Now, the specific heat of iron is something that you can look up. Nobody is expecting you to know that. We might be kind of expecting you to know the specific heat of water, which will come into the next one, but I'm just going to plug that in. 0.449 joules over grams times degrees Celsius. And so that unit there, the joules over the grams times degrees Celsius, basically crosses off the mass, and that's why we had to make it into grams, and crosses off the temperature change here. Now, my temperature change, it cooled from 198 to 85. So what we're doing here, and excuse me for 1 second while I get up and get my calculator, is we've got to take the 85, which is the final temperature, and take 198 away from it. And I have lost my calculator, but that's okay. I will just use the one on my computer. So you take 85 degrees Celsius minus, which is the final temp, TF, minus 198 degrees Celsius, which is the initial temperature. And so that's going to be a negative number. So Mr. Burr is going to do that right now. So 85 minus 198 is minus 113 degrees Celsius. So we should have something that looks like that. Okay, 3,000 grams, that's my mass. The specific heat was given to me in the problem, and then I got that negative 113 by taking the final temperature minus the initial temperature, and that is the change, the delta in temperature. So I'm just going to multiply times 0.449 times 3,000. And my answer is 152,211 joules, okay? And that's a lot of energy, but you could very easily switch that to kilojoules if you wanted to, just by dividing by 1,000, and that would be 152 kilojoules. Not a big deal. So you see, it's not that hard a problem. You just have to know what to put where. You have to be aware of what delta T is, and you also have to know that since the specific heat is calibrated to grams, you can't just plug kilograms in there. You have to switch your kilograms into grams. Okay, now the second part of the problem, if the water bath in the problem above raises from 20 to 23.5 degrees Celsius, what is the mass of the water bath? Okay, so again, I'm using Q equals M, specific heat, delta T. I have the specific heat of water, 4.184 joules over grams times degrees Celsius. I'm looking for the M. The T is going to be 3.5 degrees Celsius. And then my heat, the energy that it absorbed, we're just going to assume that everything that the sword put off was absorbed by the water. And so I'm just going to put in 152,211 joules. Now, realize that it is positive here because the water is absorbing it. It was negative when the sword was going down in temperature, but the water's actually going up in temperature. And so that also illustrates the fact that iron is has a much lower specific heat than water. It's like basically a tenth. It's much easier to heat metal than it is water. Metals just generally have lower specific heats. So all I need to do here is divide both sides by 4.184 joules over grams times degrees Celsius. 3.5 degrees Celsius, boom, boom. 4.184 joules over grams times degrees Celsius. 3.5 degrees Celsius, boom, boom. And so I'm going to 1,522 1 divided by 4.184 divided by so I have, according to my calculations, 10,394 grams of water. And let's see, to put that in perspective, if it's 1 gram per milliliter, so 1 milliliter is 1 gram, 1 liter is 1,000 milliliters. Divide that by 1,000. That's not that much. The tank is a 10-liter tank, and so you would think that that's about, like a big pop bottle is 2 liters, so 5 of those together. That's really not that much water. Shows you what the heat capacity of water can do. It can absorb a tremendous amount of heat. All right. So there was my math on that last step in case you wanted to see that. And that's a really basic heat transfer problem.